Throat cancer is a major cause of death in dragons, and it's likely due to the fact that dragons breathe fire, and fire sloshes off the cells, which makes them have to divide more and more. And cells that have to divide all the time are more susceptible to cancer. There's three main genes that contribute to cancer in these dragons, genes X, Y, and Z, and we'll talk about them further in this video. The first of these genes is gene X, which is oftentimes linked to a family history of throat cancer in dragons, which means it's more likely to be a tumor suppressor gene. Tumor suppressor genes are genes that help to tell the cell when they should stop dividing and when it should stop replicating and going through the cell cycle. So it's kind of like the brakes of the cell cycle. In a normal dragon, they'll have two normal copies of gene X. So gene X will be able to produce a tumor suppressing factor that works well, tells the cell when to stop on the right time, and will lead to having normal cells. And even if there's just one mutation in the dragon's gene X, then it can still produce that normal tumor suppressor factor because of this one good copy, and it'll likely still lead to having normal cells. But if there's two mutations, then it won't be able to produce that normal factor anymore and will likely lead to cancer. The reason that it's linked to family history and mutations in tumor suppressor genes are linked to family history is because if you already have one mutation, then it's a lot more likely that a second mutation will occur and they'll end up not having that regulatory factor that the tumor suppressor provides. Just a single mutation in one of the copies of either gene Y or gene Z can lead to uncontrolled cell growth. This means that these genes are likely to be proto-oncogenes. Proto-oncogenes are genes that encourage cell division and encourage cell growth. So which are very important to a normal cell's growth cycle. If a cell has two normal copies of a proto-oncogene, it'll produce those factors when it should, and this will lead to good positive cell growth and division. But if even just one copy is mutated, then it'll create factors continuously that just tell the cell to grow and grow and grow and grow. And this can eventually lead to cancer. In a cell that has two dysfunctional copies of the tumor suppressor gene X, but still has two functional copies of proto-oncogenes Y and Z, then something like a benign tumor might form due to the lack of regulation from gene X, but there's still being some regulation left from these two genes. Now, let's say both copies of gene X were mutated and a copy of proto-oncogene Y were to be mutated, making it into an oncogene, then something a little more serious like a malignant tumor might form, but there's still some check being put on the system from the perfectly functional proto-oncogene Z. Now, in the worst case scenario, where a metastatic tumor might form, both copies of gene X would be mutated, and both gene Y and Z would have become oncogenes, and this would cause there to be really little to virtually no regulation left of the cell cycle, and this could lead to very, very serious metastatic forms of cancer.